that is where I was not getting comfort how to prove this. Let's take an equilateral triangle. This is an equilateral triangle, meaning this is 60 degrees, this is 60 degrees, and this is 60 degrees. Yeah. Now, from here, draw a perpendicular. Okay. You draw a perpendicular, meaning this is 90 degrees. So now let's say this was my triangle ABC, and this is my perpendicular D. What I'm trying to do is, I'm trying to find out this, let's look at triangle ABD and triangle ACD. Can we say that these two are congruent?
Yes.
Come on, you guys, screen got locked. Yeah, so these two triangles are congruent, right? I can say that. Yeah. The reason, this is 90 degree, this is 90 degree, this is equilateral, so this side and this side are same. This is anyways common. So for a right angle triangle, you need RHS. So hypotenuse and one of the side. Hypotenuse are anyway same. I mean, for the original equilateral triangle, and this is common. So these two are congruent. That means this will be equal to this. Yeah. Now, this is a 30 degree, meaning this angle will be equal to this angle. Agreed? Because these two angles are 60-60. This angle also got divided by drawing a perpendicular. Because we proved these two are congruent, that means the only remaining angle is also matching. So this is 30. Now, sine 30 degree, meaning this angle, sine of this angle. Look at this one. We found that this and this are same because these two are congruent now. So this is half of the side, correct? So sine 30 will be equal to side opposite to this divided by hypotenuse. So let's say this side was A, this was A, this was A, this was A. So this is A by 2. Yeah. So this became A by 2. Sine 30 is A by 2 divided by hypotenuse, which is A. This becomes 1 by 2. Yeah. Now you can sleep well. That's where, you know, whenever there's a thing that I tell you guys that this value is this much, and if I'm not able to prove that, I get restless. But were you able to follow what I said?
Yes, sir.
Okay. Ritika, Sunarka, everybody, right?
Could you just repeat it one last time?
One last time? Okay. Now I can do it 100 times. Because we are trying to find out the value of sine 30 degree. This is the goal. Okay. What we did was, we picked up a equilateral triangle. Meaning this side, and this side are all the same. So let's say this is the side has length A centimeter. This is also A centimeter. This is also A centimeter. Okay. Now what we did was, from this vertex we have drawn a perpendicular. We just draw a perpendicular. Okay. We did not say that we are this. Right now this angle is 60. This is 60, and this whole angle is 60 because this is an equilateral triangle. All the three angles are same. Yeah. Now we have just drawn a perpendicular. So if this was, let's not say, I will say this is L, length L. Okay. So this is A, this is B, and this is C. We have just drawn a perpendicular from here to the opposite side. Let's say it meets at D. Now we got two triangles. We actually split this larger triangle into two triangles. One triangle is ABD, and another triangle is ACD. Okay. These are two triangles. We split the larger equilateral triangle into two triangles, and both are right angles because we have drawn a perpendicular. Yeah. Sally, okay?
Yeah.
Now, I'm saying that these two triangles are congruent. Why? Because these are right angle triangles. Both are right angle triangles. And for right angle triangles to be congruent, what we need is RHS. For right angle triangle, we need this theorem. Hypotenuse and one of the side. If they match, then those two triangles are congruent, meaning every other property will match. So, we are looking at these two triangles. Here, this side and this side are same, which happens to be the hypotenuse for both the right angle triangles, both the split triangles. So, hypotenuse are the same. And this side is anyway common. So, you just needed a hypotenuse and one of the side to be same, which is the case here. That means they are congruent. Now you can safely assume that they have everything matching. This angle is 90, this angle is 90, anyways matching. This angle and this angle are 60 degrees, anyways matching. This anyways had to match. So this became, this angle and this angle are same, which means this angle is half of 60, which is 30. Yep. And then, just because these two became congruent, that means the other property, this side and this side also have to match. Since these two sides are matching, earlier this length was L, so this length became L by 2. Yeah? Everybody with me? Sally?
Yes, sir.
Okay. Now this we found out this is L by 2, half of this length. Now sine 30, we know sine 30 equals this is my 30 degree angle. So sine of 30 will be side upward to this divided by hypotenuse. So side upward to this is L by 2 divided by hypotenuse is L. L by 2 divided by L becomes L by 2 into 1 by L. This flips. And then tic-tac-toe. What you got is 1 by 2. Sin 30 equals 1 by 2. Yep?
Yeah, sir.
So, now you found out that, so from this only, okay? So, now see my confidence level. So, in this table, right? 0, 30, 45, 60, 90. 0, 30, 45, 60 and 90. Sine, cos, cos 10. Sine 0 was 0 we found out. Sine 30 equals 1 by 2 we found out. Sine 45 is 1 by root 2, that also we found out. Sine 90 we have not found out. Now sine 0 is 0, which will be equal to cos of 90. Complementary angle concept. Sine of 30 is 1 by 2, so cos of 60 will be 1 by 2, matching. And again, same complementary angle formula, this will be this. Now, what we don't know is these two. If you find these two, we will get these two also. Now, same triangle, equilateral triangle, we found out that ABC, this is 60, this is 60, this is 30, this is 30. And we found this and this are same. So this is L by 2, this is L by 2 and this is L. This is 90 degree. Now, you found out sine 30 degree. We have to do, let's say, sine 60 degree. Sine 60 degree will be how much? Sine 60 will be, if this is theta, sine 60, we have to find sine of this angle. That will be this side divided by hypotenuse. So this will be, I don't know what is this. Let's say this is K. K divided by L. Now, we can find out the length of L, K, this one. Look at this right angle triangle. Here again Pythagorean theorem will apply. Meaning, if this is K squared plus L by 2 squared equals L squared. Yeah? That means K squared equals L squared minus L by 2 squared, which becomes L squared by 4. And then this becomes 3L squared by 4. Yeah? By doing this calculation. And if you want me to do that step by step, I can do that. So I will take LCM as 4. This becomes 4 is L squared minus 4 1 into L squared. So L squared. So this becomes 3L squared by 4. So K squared equals 3L squared by 4. That means K will be equal to square root of 3L squared by 4, which becomes L comes out, 4 becomes 2 squared, so 2 comes out and root 3 remains inside. Okay. So value of K is root 3 by 2L. So this becomes root 3 by 2L. This is my length, this is root 3 by 2L. So sine 60 will be equal to, sine 60 will be side upward to this, root 3 by 2 into L divided by L. Root 3 by 2 into L divided by L. Tic tac toe. What you have is root 3 by 2. So sine 60 degree became root 3 by 2. That's what you will put here. Okay. Now sine 60 is root 3 by 2, that will be equivalent to cos 30. So root 3 by 2. Yeah. Now sine 90 equals how much? So look at this. I will tell you guys something which you will not like. You might choose to laugh, but that's okay. Now this is my right angle triangle. This is 90 degree, okay? What does my sine say? Sine of theta equals the side upward to that divided by hypotenuse. Okay? Any angle, sine of that angle equals side upward to that divided by hypotenuse. See the beauty of this. Sine of 90 degree. If I say sine of 90 degree, this is, let's say this is A, this is B, and this is C. Sine of 90 degree will be equal to side upward to that, which is C, divided by hypotenuse. Yeah. So the basics remain the same. That gives you sine of 90 degree equals 1, which will be equal to cos of zeros. Now you know tan is equal to sine by cos. So you will do sine by cos, sine by cos, sine by cos, sine by cos, you will get all the values. Yeah. Anybody who has smallest of doubt or who did not like what I said or wants to give me an opportunity to say the same thing again? Anybody? Aryan, Sunarka, Aryan is not there. Ananya, Sunarka,
I understand.
Rehan. Okay, Rehan. Sarah, Neil, anybody?
I don't know. I'm just a little confused, but it's fine. I can watch the video.
Right, so keep one thing very simple, okay? So sine, cos and tan, SOHCAHTOA or whatever you call it, okay? As long as you know the basic of that, that would be a building block for this one. How these values are derived, that's what we were trying to prove. If I want to just give you guys a clue, okay, I'm not going to do it again because that might not be very productive for you as well as everybody else. You guys anyways are blessed to have the video for your reference anytime and every time you want to. But the clue here is, if I'm trying to find out 45 degree, meaning I will make a right angle triangle with 45 degrees. Meaning it becomes a right angle triangle as well as isosceles triangle. Because if I have both the angles are 45 degrees, that means this side and this side will be same. We'll use that to find out. So then you'll apply Pythagorean theorem. This side are same. Square of this plus square of this will be equal to this, and you find out this length in terms of this and this guy. That is your clue. Now if you're trying to prove or find out the value of sine 30 degree, you will draw a equilateral triangle. Equilateral triangle 60, 60, 60, all 60, meaning all sides same. Then you draw perpendicular from here, and then you prove that this triangle and this triangle are congruent. As soon as you found that these two triangles are congruent, then this side and this side becomes the same. And then you apply sine 30. And this angle becomes same. So 30, 30. Then you find out sine 30. This side you know, this side you know. And apply sine. I mean, how do you derive sine 30? You'll get that clue. Now, you got sine 30. Same thing. Now you have 30 here, 60 here. For finding sine 60 degree, you need to find the side upward to this, divide by hypotenuse. You have to find out the length of this side using Pythagorean theorem again. Okay? And then you can prove that. So Aranya, what I would suggest is probably whatever I told, look at this and I mean, use this as your guiding principle. See why I was stuck. I was not stuck because I didn't know how to prove it. I was stuck to figure out how do I get to this situation to be able to derive this. And that is where I was taking time.
Okay.
Yeah. So as soon as you get a clue, then everything is smooth. So you use this clue and then watch the video once. And when you guys are watching the video, again, you guys are not watching the video for getting more views for me. Okay, that is not the purpose. You are watching the video for your use, for your advantage. How you can do that? You're watching the video, you get some concept, pause it, and then try doing it yourself. Because math is all about getting your hands dirty. Dirtier the hands, easier the concepts. This becomes the punchline for today. Dirtier the hands. Hey Arnav, you have joined 7 minutes early. You are in the.
Sorry, I'm in the wrong class.
It's okay.
I'm so sorry.
It's fine, beta.
I'm so sorry. I'm in the wrong class.
It's okay. So what I'm saying is, more dust you see on your hand, more comfort you will build with maths. So watching video, pause it, and then do it yourself. Because more you do it, more comfortable you'll get. All right. So this was the table, how the values are derived, how do you relate the angle with the radian. That is all we were learning today. And the last thing that we wanted to touch upon was the standard circle theorem. But before I go there, any questions, any doubts, anything that you think you would want me to go back to?
No, sir.
Okay. So let's look at the standard circle theorem. X minus k squared plus y minus L squared equals R squared or M squared, whatever it is. If I have an equation like this, I will call this as a circle theorem or standard form of the circle theorem or circle equation, whatever you call it. If you have, let's say, x squared plus y squared equal to 15, this is a quadratic equation. This draws a parabola, right? This one, when you see, or easier correlation. If you see something like only square of one of the variables, that's a parabola. If you see square of both the variables, so this is parabola, this is parabola. If you have square of both the variables, this closes. Okay? So that would be a dirty way to recognize it. Okay? If you have an equation like this, and then you have an equation like x squared plus 2y minus 17 equal to 4x. Which one is a circle? Which one is a parabola? Simple dirty method would be look at both the variables. Do you see maximum power to the variable as 2 for both the variables or only one? If you see only one variable having power 2, that's a parabola. If you see both the variables having power 2, maximum power up to 2, that's potentially a circle because it's closed. Yeah. So now when you look at, so we are not going to talk about parabola, we are talking about the circle theorem. So this is the standard form of a circle equation or circle theorem, whatever you call it. I will not call it circle theorem, this is a standard form circle equation for standard form of a circle equation. Here, if you look at this, K and L are the x and y coordinates of the center, and this R is the radius. That is how you can relate it. If you see an equation like this, from this you can derive what are the coordinates of my center and what is the length of the radius. So let's say if I give you guys an equation like this, okay, x x square plus y square plus 4y minus 4x equal to 17. Okay, and I say, okay, find out the center, coordinates of the center and the length of the radius from this one. What you will do is, you will try to convert this into this form. Try relating it in this form. So you have x squared. Can you find out x minus something or x plus something square? So look at this. If I say x squared minus 4x, what I need? Plus 4 to make it a square form. Let's say I have y squared minus plus 4y. Y squared plus 4y. What do I need? Another 4. To make these two in a square form. This becomes a minus b whole square, this becomes a plus b whole square. Okay. Now what did I do? I added 4 here and 4 here. So I have to add 4 here also. 17 plus, sorry, 4 plus 4, 8 here. Now you see this. It becomes x minus 2 whole square plus y plus 2 whole square equals 25. So Akshara, you are a little early. Just bear with me for 2 more minutes. We'll wrap up this class and then I will talk something that will be more relevant to you. Okay? Alright. So, from this equation, what did we do? We converted into the standard form. Now from this, we can find out what are the coordinates. See, what is the radius? 5. This is 25 is 5 square. R square. This is the radius. What are the x and y coordinates? So, what is the value of k here? K equals 2. What is the value of L here? L equals minus 2. Yeah? Correct? So, if it was y minus something, y minus L, what we have is plus. So, my x and y coordinates are 2 and minus 2 here. So, I know it was way too quick. We'll probably spend some time on this one. We'll try dealing with some of the equations and use or convert that to standard circle form, and from that we'll try deriving the x and y coordinates and the radius. And then we'll also see, if I have an equation, how do we move the circle? If the circle has to move, how the whole equation changes. So we'll look at all those in the next class. That is where I would want to stop. Otherwise, you guys will all get loaded and it will be difficult to relate or grasp everything that we have done so far. So just a recap before we all leave. We have talked about how to derive the value of sine, cos and tan, 0 to 90 degrees, how to prove that. Then we looked at what is the relation between degree and radian. It's all the same, just that we have to know the conversion formula. And then we looked at the standard circle form of the equation, and then how do we relate that for finding the x and y coordinates and the radius. We just touched upon the concept. We'll probably use the next class for practicing a little bit more so that we feel more confident about what we have learned. Okay, so with that being said, I will pause here. Any questions?